Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of one sample sign test, and this video in particular is just the first part out of four parts related to this idea. And to start off, I'm just going to give a simple introduction to the idea, and we're going to look at the first point here, which is the measures of central tendency that are commonly used. They are the mean and the median. And I'm sure you are already familiar with parametric procedures, and this procedure here is usually concerned in studying the population mean. For example, this could be the hypothesis that you are interested to look at. That mean takes a certain specific value, mu naught, and this is the alternative hypothesis, and you can see clearly that the hypotheses given here are complementary in nature. And so in most cases, certainly the population variance is unknown, therefore the t-test procedure will be employed. And if, let's say, the sample size is large, you can have another option, which is to use a z-test. Now let's talk a little bit about the t-test procedure. This procedure here requires several assumptions to be fulfilled before you can use it. And an example here is it requires population from which the sample has been drawn to be normally distributed. So how can you tell if the assumption is fulfilled? You need to check your data, obviously. For example, you may want to do some sort of test, or you may want to plot your data to see whether it follows the normal distribution or not. Now, what happens if there is a modest departure? Well, for t-test, it is known to be a robust procedure, which means that if there is a slight deviation or a modest departure from the normal assumption, you can still use this procedure. But if it is seriously violated, then you really need to think of an alternative solution, which is you need to start thinking about the non-parametric approach. Now here is just an example to show how you can check the assumption of normality. And in this website, for example, it talks about checking the t-test assumptions with R code. So if you are having some free time, you can go on and check this website here. The common method to check normality assumption is by using Shapiro-Wilk test. And in this test, the null hypothesis here will always be that data here follows a normal distribution. So data follows a normal distribution. Therefore, if you get p-value greater than the chosen significance level, so let's say alpha is your significance level and p-value here is greater than alpha, that means you can conclude normality of data, because you cannot reject the null hypothesis. You will have to accept the null hypothesis when p-value is greater than alpha. So this is something that you have seen before in parametric procedure. You can only reject null hypothesis. Okay, so in general, you reject the null hypothesis when p-value is less than alpha. So when it is greater than alpha, you cannot reject it. So if you cannot reject this, that means you can conclude your normality of data. So that's the idea. Just a quick idea. Okay, so if you want to know more, please go on and check this website. Also, you can perhaps try to visualize the whether data is follow the normal distribution or not by using QQ plots. So here is an example of a figure here where you can see that lots of the data points lie on a straight line, and each sort of indicates that the assumption of normality here is fulfilled. Now, another website that you may want to check out is this one here. So this is an example that shows the departure from normality, and in this case, t-test procedure should not be employed in the scenario given here. So you can see that data here does not lie on this straight line. So it has a lot of deviation on this side and also that side. Okay, so that is an example of data set that deviates from the assumption of normality. And this is another website that also gives insight to the idea of QQ plots. So it says here, if data comes from a normal distribution, then you will expect all our data to lie on the straight line here. This is an example of data set that comes from that has light-tailed, left skewed, so it looks like this. If you have a bimodal distribution, it may look like this. So this is the theoretical idea. However, when you have or when you collect your data set, it might not look as similar to the theoretical representation. So as an example, if you collect your data set, it might look like this. So this could be interpreted as data coming from a normal distribution. In practice, you cannot expect your data set to be lying on the straight line as perfect as this one, but there will be some sort of slight deviation over here, and it's okay. And based on this QQ plot, you may suspect that the normality assumption is fulfilled. So here is the theoretical representation. This how your in practice how your data plots may look like because of some sort of randomness when you take your data or you sample your data. Okay. Well, I think that's all for now. Thank you very much, and I will see you in the next video, the second part of the video related to this one sample sign test. Thank you very much for watching.